Hi, you guys. This is Mr. Aguilar here in my classroom in P104. You guys asked for a study guide for something that you guys can review. I'm going to kind of jump into this. You guys should be able to print this out. It's in both the attachments for both the Word document and PDF form. I don't want to take that much time talking about this. I want to jump into it. I want to make this very short. There are only 7 slides that are talking about this material. Everything else is pretty hands-on. You guys will be able to do a bunch of this material by yourselves. You guys can skip ahead, view how you guys want to view this. We talked about the first one being which statement is true about the rhombus and rectangle. The best way to do these is to draw them out. Looking at this, sorry, it's not the best rhombus and a rectangle. You got to know about the key parts of it. We're looking at the diagonals in a rhombus form a perpendicular bisector, and we know that in a rectangle the angles are right. From that, we can kind of conclude that it's both true. Both have congruent diagonals, and the diagonals of a rectangle, we do have that the diagonals are not congruent. Okay, we can create a rhombus that is longer and shorter sides with different angles. The perpendiculars both have perpendicular diagonals. That's not true. The only one that does it here is our rhombus, and the last case, both have diagonals that intersect each other, is true. Both of our cases that we have here form a perpendicular, a bisector that splits it up into even parts, and that's what we really want to look at. The other ones that are down below is being able to key identify these parts that are into it, state whether each figure is a rectangle, rhombus, square based on the information. The key thing for this one is looking at what information is provided to you. I'm looking at a polygon with 4 angles that are 90. It doesn't tell us that the sides are congruent, it only tells us that the angles. So from this, I would say it would be a rectangle. The next one gives us both 90-degree angles and sides that are congruent. There's only one figure that has that, and we call it a square. Sorry, it kind of jumps around. The next one, not giving us the angles, it only tells us that we only have a 4-sided figure that are all sides congruent, and we know that has the only one to be a rhombus. And our last case that we're getting here is we have opposite sides are congruent. We don't know anything about the angles, so we can't say it's a rectangle or a square. So it just has to be a parallelogram. Having these written out, you want to make sure that you guys are correctly doing these. Test them out by yourselves before you try them, before I review them. It's kind of nice too. Let's go to the next slide. This is our second one. Pause the video, try these out. I want to continue just to make sure we're understanding what we're doing, but try them out on your own before we do this. Again, you guys have everything written out for you, so give it a go. State whether it's true about every polynomial, or state whether the following are true or false about a parallelogram. The good thing about it, you guys have a picture up there with a parallelogram. I want to try to be able to kind of write this out or draw it. Oh, it's a bad parallelogram. Diagonals bisect each other, opposite sides are congruent. You guys already have the figure in front of you, so yours might be a little bit better than mine. We know that diagonals bisect each other evenly, so I'm going to try to mark those up. Opposite angles are congruent. Okay, sorry, that's kind of rough, really rough. But looking at our figures, we want to be able to see which ones apply to which statement. The first one being opposite sides are congruent. This is true inside of a parallelogram. Consecutive angles are congruent. In a parallelogram, we know that consecutive angles or angles that are right next to each other are supplementary. So this is false. Diagonals bisect each other. Bisecting means it splits it into two, and we do have the bisectors. So we do see it splits it in half. Opposite sides are parallel. We do have opposite sides that are parallel. That's the definition of it being a parallelogram. So we want to be able to apply those. The one figure down below gives us a quadrilateral. It doesn't tell us that it's a parallelogram, even though it might look like it. Let's see. Oop, lights turned down on me. It's okay. We want to be able to see the next part about this. So looking at the figure quadrilateral that we see here, EC is 10. So I'm going to go ahead and on my figure, I'm going to kind of go ahead and draw directly on top of it. EC is 10, so I'm going to kind of mark that 10. And we know AE is 3x minus 5. So because we have those parts and we know that in a parallelogram, the bisector splits it into two, we can actually make those separate equal to each other. So I'm going to get 3x minus 5 and 10. We're going to add 5 to both sides to get 15, divide by 5, and we're going to get 5. What is the value of x to make that a parallelogram? So we want to be able to see that. Give me 1 second. I'm going to try to get these lights back on. There it is. I'm sorry. So here we go. That's the problems we want to make it. We know that for it to be a parallelogram, opposite sides the diagonals must be congruent. I'm switching over to the next one. You guys can do these on your own. I'm sorry if the video kind of cuts it off, but it says determine the word belonging to each blank for number 9. Number 6 is to find out a little bit about the quadrilateral and what it's asking for. So let's go ahead and begin. Pause it, check your own work, and we'll continue. In quadrilateral, QRST, QR and TS are congruent. They give us that figure. Which conditions does not ensure that QRS is a parallelogram? So which conditions does not ensure that it's a parallelogram? So let's see. QR and TS are congruent. Let's see if that makes it sense. We need that to be ensured to make sure that it is we need to make sure that it is congruent for it to be a parallelogram. Opposite sides are congruent. Q and T talks about the supplementary angles. Do they necessarily have to be? Let's see. Let's look at that one. So this is a potential one. We have QT and RS. QT and RS need to be parallel. We definitely need to ensure that those are parallel, and we know that we have to have opposite sides for them to be. So I'm guessing the only one that doesn't make sense is this one. So your direct answer would be B. Q and T are supplementary to T to not ensure that it is a parallelogram. Maybe I'm reading it wrong, but I'm hoping not. Determine the word belonging in the blank. A square is a parallelogram. This is always true. We can look at our chart of how it kind of goes upward in the rankings. We looked at the overall quads. And then from there we said kite has no parallel sides. We have trapezoid. And then we had parallelogram. And then to fit that in further, we said rectangle, T-A-N-G-L-E, sorry, and a rhombus. And then if it fit both of those categories, we called it a square. So what you want to be able to see is as long as you can go up and down one of those trees, we can actually determine what we're going to see. So a square is always a parallelogram. It has congruent sides by definition. A parallelogram is a rhombus sometimes, right? A rhombus, a parallelogram can sometimes be it. By definition, for it to be a parallelogram, opposite sides must be congruent. So we know that that has to be sometimes. Not all the times will it be it. It can sometimes be a rectangle. It could sometimes be a square. So as long as it fits on that category tree, we're going to be okay. A kite is a quadrilateral. A kite is blank a quadrilateral. A kite is always a quadrilateral. Okay, quadrilateral by definition is just a four-sided figure. A kite is a four-sided figure, so it is a quadrilateral in this case. So we have always, sometimes, and never for these questions. I hope you guys got those. Hint, hint, we're going to have some of those tomorrow on the test. Okay, here we go. The next one that we're seeing here, we have a parallelogram. It tells us to find the angle measures, and we can RS, the measure of angle S, and the measure of angle R. So the first ones that I want to be able to see here is measure of RS. So RS and these two are congruent. So we're going to go ahead and set those equal. So I'm going to get 2x is equal to x plus 3. I'm going to subtract out x. X is going to be equal to 3. And I get x is equal to 3. Is that what it's asking me? No. I'm looking for the value of RS. So I want to be able to plug in RS. RS is equal to 3 plus 3, or 6. That is my true answer. Read the question. You got to read the question. Angle S and angle R, we can find those both out. We know it's a parallelogram, so consecutive angles or angles that are near each other are supplementary. So I'll change up the color. Let's go blue. I'm going to go 10n plus 8n is equal to 180. We're going to add these two up and get 18n is equal to 180. Therefore, n is going to be equal to 10. Okay, that's a variable. Again, that's not what we're looking for. I'm looking for the angle S and R. S, the measure of angle S is 10n. So 10 times 10 is 100. So that's my angle S is 100. And our last case, angle R, is equal to 8n. So 8 times 10 is 80. We should check to make sure. If we add those up, we do get supplementary angles, and we're good to go. Okay, I hope you guys tried those out. Good practice. If they were across from each other, we would set them equal to each other. But in this case, because they are supplementary, we're going to be okay. Moving on. Long figure, we're looking at this one. It asks us a lot of stuff about the parallelogram. So we're looking at properties of parallelograms. Pause it, try these ones out. There's not that much multiple choice on the test, but it's good just to kind of reflect on what kind of other questions it's asking for. AB, I'm going to kind of draw directly on this. So AB, in our case right here, is going to be, for number 1, AB is 4.7, and then I'm going to get BD is, let's see, BD, this whole thing is 10.6. Okay, it's asking us for what CD is. So it's asking us for either the side of the angle, and I'm going to kind of highlight that CD. It's asking us for the length of CD. In that case, because we have a parallelogram, we know the opposite sides are congruent. So this has to be 4.7, which has to be A. Which statement is not true about it? So I'll change up the color. We're going to look at the statements. So AB and CD are good. That statement is true, so I know I can get rid of that. We're looking for the not true statement. So AC and BD. So AC and BD. We're talking about the diagonals in here. In a parallelogram, don't necessarily have to have congruent parts. So this is not true, okay? And let's just check the last one to make sure. AD and BC. AD and BC, which is the top and bottom parts, are known to be true, so we're going to cancel those out. We're done. To help out the figure, I'm going to kind of erase all these bad stuff so I can kind of see it. You guys will have probably better penmanship than me. to kind of draw on this. So let's kind of go back to black. What is true about angle ABC? So ABC, I'm going to highlight this. So we're looking at this bigger angle. So let's see what we can do. AB is supplementary to BCD. So BCD, they're next to each other. That would make sense. That is true. But let's just make sure that the other ones are false. ABC is congruent to BCD. So BCD, nope, they're supplementary. Definitely not that. They're consecutive angles. And then ABC is congruent to BEC. So BEC, we're talking about this inner angle in here, which is not even close. So the only one that it can be is A. Okay, is A. And I think Darth Maul approves back there. So we're going to kind of be happy with that. Okay. Here we go to the next one. Again, pause it, check it out, see what you guys can get, and come back. This is not really solving anything. It's talking about a parallelogram. Again, a lot of stuff we talked about the last couple of weeks have been about parallelograms. So let's kind of plug in what we know. The good thing about this is we can fill it in because we know it's a parallelogram. So I know the opposite angle, this is 40 degrees. I know that my bottom angle is X, my other side is Y. The angles are supplementary, or not supplementary. Oh, yeah, supplementary. So I know that this is 120, or, ooh, not 120, 140, right? They're supplementary. It means they add up to 180. I don't know where I got that. So is angle C 50? No. Okay. They're opposites to each other, so it definitely has to be 50. Is ABY? True. We just drew that in. Draw as much information as you can, especially if you know if it's congruent triangle. And then angle B is 40, 140. We know that to be true because these two angles are supplementary. Okay. And then we know AD is Y plus X. No. AD is just X. So this is false. Okay. So just practicing a little bit more and doing these will help you out in the long run. I'm going to jump to the next problem. Okay. Hopefully we're kind of coming to the end. I believe we are. You guys should be able to do this problem. I highly recommend you do this problem by yourselves. So pause it if you need to. I'm going to go ahead and continue this, but do so at your own speed. I'm looking at this, again, parallelogram properties. We're not looking at any angles. There's no angles that it's providing. It's looking at the side. So let's kind of pull those in. So AE is 3x plus 4. I'm going to get EC is 2x plus 8. And then I'm going to get BE is 4y plus 1. So it looks like we're looking at the diagonals. And then BD, so we're looking at the total thing, is going to be 18. So which is good, which is interesting. Okay. If I know that to be 18, I know that each part of these is 9 and 9. So I want to just make sure I point that out. It bisects it evenly. So what are the values of x and y? Well, let's solve it out. Solving for x, we know each part of those are congruent. So 3x plus 4 is equal to 2x plus 8. We're going to go ahead and simplify that out. I'm going to subtract it out. Get x, right, 3 minus 2 is 1. And then we're going to get 4 on this side. So our x value is equal to 4. Our y value, since we split up the diagonal bisector, I know that half of 18 is 9. So I'm going to go ahead and set 9 equal to 4y plus 1. That's what we want to solve out for. I'm going to get 8 is equal to 4y divided by 2 is equal to y. So y would be equal to 2. Okay, easy enough. I know you guys are getting these down pretty well. Practice your guys' study guide. Very, very helpful. Looking at EC, what is the length of EC? We know the length of one of them to be EC right here is 2x plus 8. Ooh, sorry. But we're going to go ahead and plug in 4. So EC is going to be equal to 2 times a value of x, which is 4, plus 8. So I think it's going to be 8 and 8, which is 16. So the length of EC is 16. The length of AC, so we know that one part of this is 16. We don't even have to solve out the other one. So AC is the total length of it, which we're just going to double and get 32. It's that full length right here to AC. If half of it is 16, the other half has to be 16 as well. What is the length of ED? ED is the other portion to it. We already know that half of it, of BD, would be 9. So we know that the last part was definitely 9. As long as you guys have this intuition, you guys can definitely do this. Okay, so don't struggle with them. Feel free to comment on these as well. That's pretty much it. I'm hoping we're going to be able to draw on this. Okay, I don't think so. I'm going to go back for these. I don't think it can. Okay, I don't think it can. Looking at the end of this material, we want to be able to talk to you guys briefly. Please study the properties. A lot of the properties come up. Know what the questions are asking for. Know how to apply them and where you're solving for, and look at the values of what is congruent, what is supplementary compared to angles, that kind of stuff. Besides that, I want to keep this very short so you guys have enough time to study. If you have any questions, please email me. I'll be up for a while. It's 5:40 right now, so it should be posted very shortly. I'll see you guys. Say bye to Batman or Spider-Man. Bye, guys.